2.6 graphing rational functions. So graphing rational function is if you take something like this and how would it look like on a graph. Okay, so there's a lot of parts that go into it. First, you need to know how to factor. So everything should always be factored. And then there's a couple things you got to do. First, you got to know what a vertical asymptote is. So the vertical asymptote, so I give you how to find it here. And then there are holes. These are you find holes. Horizontal asymptotes, oblique asymptotes, and so on. So in class, I went through what every one of these meant and how to do them. But I think for this video, it's beneficial if you see an actual problem happen. So let's look at the first one. So the first thing you should always do is, can you factor? So on the top, you can factor the top. On the bottom, you can. On the bottom, we can factor this, and it becomes x plus 3, x minus 3. So once you have your function fully factored, then there are 5 things that you have to do. First thing, is there anything that will reduce? These will reduce, and I have 1 over x minus 3 left over. So the most important thing is when you reduce, the holes appears when reduced. So when I reduce x plus 3, that creates a hole. That's why we don't say cancel, because cancel means disappeared. But it creates a hole at x plus 3 equals 0. Or it creates a hole at x equals negative 3. Okay. And you can have one hole, you can have more, you can have as many as you want. Next is finding the vertical asymptote. The vertical asymptote is when you take the bottom. So you want to take the bottom and you want to solve for x does not equal 0. Or x equals 0, your choice. It's really the same thing. So I'm going to take the bottom, x minus 3. And I'm going to say x minus 3 is equal to 0. So there's a vertical asymptote at x equals positive 3. This is my vertical asymptote. Step 3 says find a horizontal asymptote or an oblique asymptote. If you go up to the top, I give you a guide map to the horizontal asymptote. So this says, if I look at the exponents, if the top is less than the bottom, then my horizontal asymptote is automatically equal to 0. If the top is bigger than the bottom, there is no horizontal asymptote. And if they are the same, then I have to divide the numbers. So for example, this example, since these two powers are the same, my horizontal asymptote is if I divide these two numbers, which is 3 over 2. Okay. So let's go back. If I look at my exponents, on the top I have an exponent of 1. On the bottom I have an exponent of 2. So that means the bottom is bigger than the top. Bottom is bigger than the top. My horizontal asymptote is y equals 0. So then we got to find the x-intercept, the y-intercept. So the x-intercept is the top. So x-intercept is top equals 0. So if I look at this one, you have to go to that one. You can't go to this one because we already did a reduction here. So I take the top. 1 equals 0. Well, 1 does not equal 0. We know that. So that means no x-intercept. Sometimes you might get something like 3x plus 2 equals 0. Then the x-intercept is negative 2 over 3. Right? You're solving. If you can solve, you solve. If you can't, you can't. Y-intercept. Y-intercept is when you replace x with 0 So I can take this. So I have 1 over 1x minus 3. But then I can replace x with 0, and I get 1 over negative 3. That is my y-intercept. We'll do this one in a bit. So let's plug it in. So let's start with the vertical asymptote. Vertical asymptote at y at x equals negative, or x equals 3. So here's my line, x equals 3. And then I have a horizontal asymptote at y equals 0. This is y equals 0. Okay, and then let me label my intercepts. I don't have a x-intercept, but I do have a y-intercept. Negative 1/3. Negative 1/3 is just, it's in between negative 1 and negative 2. So right here. Right there. So this graph is divided into 2 parts. It's divided into this part, right, the left side of the green line, and this part, the right side of the green line. So your job is to determine, is my graph going to start here, close to the asymptote, and end up here, like this? Or is my graph going to start here and end down here? And on this side, is it going to go like that, or is it going to go like that? So there's a couple of tricks that you can use. The first trick. If my line has to hit this point, I have to hit that point, then that gives me a good idea that my line does not come from here and hit it and go down. Okay. There are times where your line can cross the horizontal asymptote. It doesn't happen often. And also, you know that since we don't have a x-intercept, we cannot cross the x-axis. So that gives you a hunch that this line is down here. Okay, because we had to hit that dot. On this right side, notice that there is no dot for us to go through. So we got to decide, is it going to come from up to dot bottom or like that? How you do that? If you take, so if you look at this green line, this asymptote, I'm going to find any point over here. I'm going to choose a point. So any of these lines. So let's say I choose the point, this point. This point is x equals 4. There has to be a point along this line somewhere. It could be here, it could be there, I don't know. But when I choose x equals 4, whatever my y is, that tells me where the graph is going to be. So let's go back to my equation here. 1 over x minus 3. If x is 4, this is 1 over 1. So what that tells me is that a combination of this and this, there is a point on my graph 4, 1. 4, 1 has to exist. 4, 1 is right here. This is 4, 1. So because that's on the top of this orange line, that means that there must be a line that comes and hit that point and goes like that. Okay. Let's say the answer is 4, -1, and the point's down here. Then you know that the graph must come from the bottom, hit that point. So to find where that point's going to be, pick a point and plug into the equation. See if it's above this orange line or below. So that's a complete graph, almost. Last thing we got to do. Don't forget about the hole. There's a hole at x equals -3. So here's -1, -2, -3. Then on your graph, on your line, draw a circle. See, that's a solid circle. That's an open circle. So that's how you graph it. Okay. They're all very similar. Factor, can you cross anything out? Horizontal asymptote, vertical asymptote, things like that. So there's one more called the oblique asymptote. So let's do this one. So this one, I'm going to leave some of the work that I've already done up here, just to save a little bit of time. But the first step is to factor. And I factor this to this. I just use PQ, something that you know to do. And I factor this to this. So I factored. Can I cross anything out? Yes, I can cross those two out. Because I cross those out, there's a hole at x equals positive 1. So then I have left over x minus 3, x plus 2, x plus 3. So then I have a vertical asymptote, x equals negative 3. Again, I'm using the bottom. Horizontal asymptote, well, the power on the top is x squared. The power on the bottom is just an x squared, because I have x and x. So that means that there is no horizontal asymptote, but there is an oblique asymptote. An oblique asymptote happens when the top is exactly 1 bigger than the bottom. When that happens, we got to do synthetic division or long division. So the top, if I redistribute this, this is x squared minus x minus 6, and then the bottom is x plus 3. If I do my synthetic division, 1, negative 1, negative 6, negative 3, negative 1, negative 3, negative 4. Okay. So this is x minus 4. That is my oblique asymptote. So you graph this the same way you will graph a y equals mx plus b. So actually, let's graph that right now so you see what I mean. So I start at negative 4. Start at negative 4. I'm going to go up 1. This is your slope. I'm going to go up 1, right 1. And it's going to go like this. Okay. So that's an oblique asymptote. And then let me pair that up with my vertical asymptote at negative 3. Okay. And then find your x-intercept, your y-intercept. X-intercept is, so again, you're using the top. X minus 3 equals 0. I'm getting that from here. And x plus 2 equals 0. So x equals 3. X equals negative 2. 3, negative 2. And then I have to do the y-intercept. So there is a trick for a fast y-intercept. The trick to the fast y-intercept, those numbers, negative 6 over 3, which is negative 2. It's right there. So let's focus on the section of the graph that I do have a dot. So there has to be a graph that hits this dot, hits that dot, and hits that dot, and then goes up like that. Right, the graph has to hit all of them. I need to decide. So there will not be a graph on this side. There will not be, because you cannot have a line up here and a line down here. So I need to decide, is the next one going to be up here, or is it going to be down here on the left side of the red line? Using your intuition, if a graph was to go like this, it will have to cross this point, but we already know that there is no point there, because that would be a x-intercept. So therefore, we know that the graph has to go. So that is using your intuition to find it. Okay, so it just takes a lot of practice, but if you just follow these 5 steps, you're going to get it right every single time.